Hello everyone, and welcome to this tutorial on bearings. So what is a bearing? Well, a bearing is simply an angle, but it's from the north, a clockwise direction, and written in 3 figures. But why, you may ask? Well, this is because bearings is more informative than a normal angle. Bearings are used in marine and aeronautical navigation because wherever you go in the world, the north is always the same. The clockwise direction is always the same, and 3 figures helps us minimize any confusion. So, bearings are a powerful worldwide application of angles. So now we know what a bearing is. It's important to note there are 2 different types of bearing questions given in an exam. One type is where you are required to measure using a protractor, and the other is where you are required to calculate the angles, so you can't use a protractor. In this tutorial, you will need to know how to use a protractor, have knowledge on angles with parallel lines, have knowledge on angle facts associated with triangles, and knowledge on trigonometry, as well as forming and solving equations. So let's start with some questions requiring a protractor. Here the question shows a map, and there are 2 positions, ships A and B, with a port O. We're given the scale on the map to be 1 to 25,000. The question wants us to identify the bearing from the port to ship A. Now what's very important to note is the question does not state diagram not drawn accurately. Therefore, we are required to use a protractor. So looking at our question, let's apply our knowledge on bearings. First things first, let's identify our starting point from our question. Well, it says we need to start from the port. So that would be our first starting point. So let's identify the north from the port. From here, we're going to ship A. Therefore, let's identify the line which connects the port to ship A. Now we need to identify the angle from a clockwise direction from our north. Here you can see this would be the angle we're being asked to work out. Getting our protractor ready, we're going to rotate it round and line it up so that we have the port is right in the center of our protractor and the north is in line with our 0 degrees. From here, we're going to read our protractor and identify the bearing from the port to ship A. 0, 10, 20, 30, 40, and slowly counting, we can see we have a bearing of 044 degrees. Remember, a bearing must be written in 3 figures. Don't worry if you didn't get exactly 044 degrees. There's always a little bit of leeway in any mark scheme. So now we know the bearing from the port to ship A is 044 degrees. The next question asks us to work out the bearing from ship A to ship B. See if you can give it a go and press pause if you need. Reading the question, we need to start from ship A. So let's apply our knowledge of bearings and identify the north from ship A. The question wants us to go to ship B. So identifying our length, it's clear that we need to find this angle as it is in the clockwise direction from our north from ship A to ship B. Now getting our protractor ready, just like before, the center of our protractor must be at that ship A. Making sure 0 is in line with our north, then we can count in our clockwise direction. From 0, counting 10, 20, 30, 40, all the way around, you can see we can identify our bearing from ship A to B as 162 degrees. Now let's have a look at a slightly harder question. Here the question states that the map shows positions of different locations on an island. The scale of the map is 1 to 24,000. The question wants us to identify the bearing from the hospital to the cathedral. Just like before, the question does not state diagram not drawn accurately. Therefore, we must use a protractor to answer the question. See if you can give it a go and press pause if you need. Reading the question, we are starting from the hospital. So using our knowledge of our bearings, let's identify the north from the hospital. And we're going to the cathedral, so let's identify our line from the hospital to the cathedral. Because bearings always go in a clockwise direction, it's clear we need to work out this angle. Getting our protractor ready and lining it up just like before, you may notice that my protractor doesn't let me go all the way around to measure this reflex angle. So you have two different methods. You can make a note of 180 degrees and then measure this angle, or alternatively, you can measure the anti-clockwise angle by rotating your protractor round and lining up the protractor just like before, so the center of our protractor is at the hospital. Reading the anti-clockwise angle, you can see from here, which is our north, this is our 0 degrees. Counting up, we have an anti-clockwise direction of 130 degrees. Because we know angles around a point sum to 360 degrees, we know the clockwise direction has to be 360 subtract 130, which gives us 230 degrees. Therefore, the bearing from the hospital to the cathedral is 230 degrees. Now the second part of this question is a little bit tougher. It states that the police station is on a bearing of 040 degrees from the hospital and a bearing of 290 degrees from the stadium. We're asked to draw on the map the position of the police station and label it X. See if you can give it a go and press pause if you need. Getting our protractor ready, we need to start from the hospital as this is our first bearing. Lining up like we've done before, ensuring the center of our protractor is on the hospital and identifying the north is on our 0, we're going to identify the 40-degree angle. 0, 10, 20, 30, 40 degrees. So therefore, we know the police station is anywhere on the bearing of 040 from our hospital. Now let's have a look at our stadium. Identifying the north from our stadium, I know I need to draw a 290-degree angle from our stadium. Now because my protractor only goes to 180 degrees, I'm going to go anti-clockwise 70 degrees, as this is the same as 290 degrees clockwise. So rotating my protractor round, ensuring I line up the center of my protractor with the stadium, and my north is on my 0, I'm going to count 70 degrees anti-clockwise. 10, 20, 30, 40, 50, 60, 70. So I know the police station is on a bearing of 290 degrees clockwise or 70 degrees anti-clockwise from our stadium. Now, removing my protractor, you can see we have a point of interception. This point is on a bearing of 040 from our hospital and 290 degrees from our stadium. So therefore, the point of interception is the police station, as it satisfies both of our bearings. Now let's have a look at a different type of bearings question. Here you can see the question states that the diagram is not drawn accurately. Therefore, we know we cannot use our protractor. We need to work out the three-figure bearing of D from C. We need to use our knowledge on angles with parallel lines. The great thing about north is every north is parallel. So that means we can use our knowledge on parallel lines. The question states that we are starting from C. So, identifying our north from C, and we're going to D, we know this is the clockwise angle or bearing we need to work out. Given our knowledge on parallel lines, we know these are co-interior angles and they sum to 180 degrees. Therefore, we know 180 subtract our 85 gives us 95 degrees. Therefore, the bearing of D from C is 0.95 degrees. Now let's have a look at a slightly harder question. Again, it states that the diagram is not drawn accurately, so we know we cannot use a protractor. The question states that the diagram shows 2 points, S and T, and the bearing of T from S is 0.43 degrees. We're asked to work out the bearing of S from T. See if you can give it a go and press pause if you need. From the question, we are starting from T, so let's identify the north from our T. From here, we're going to S, so this is the angle that I need to find. This is our bearing. Now, to work out this bearing, it's clear we need to work out the interior angle first. I'm going to label this as X. Now, using our knowledge on co-interior angles summing to 180 degrees, we can work out X to be 180 subtract our 43, which is 137 degrees. Now, we know the sum of angles around a point is 360 degrees. So, labeling this as Y, I can work out my bearing. 360 subtract our 137 gives us Y. Therefore, the bearing of S from T is 223 degrees. Now let's have a look at a slightly harder question. Once again, the diagram's not drawn accurately, so we know we cannot use our protractor. The question states that the bearing of B from A is 62 degrees. C is due south of B. In other words, we know we have a straight line. We're asked to work out the bearing of C from A. See if you can give it a go and press pause if you need. From this question, we need to use our knowledge on angles with parallel lines and angle facts associated with triangles. This is because we have norths which are always parallel, and you can see we have an isosceles triangle. So let's start by identifying what the question wants us to find. Well, we need to work out the bearing of C from A, so we're starting at A. Identifying our north from A and going to C, it's clear this is the angle that we need to find. We know this is 62 degrees, so therefore we need to work out this angle in order for us to know the bearing of C from A. Now, let's use our knowledge on co-interior angles. I'm going to call this angle Y. Now, given I know co-interior angles sum to 180 degrees, therefore Y is equal to 180 subtract our 62, which gives me 118 degrees. Now I know Y, I can work out this angle, which I'm going to call X. Well, I know X and Y sit on a straight line, So therefore, I know x is 180 subtract 118 to give me 62 degrees. Another way to verify that x is 62 degrees is using our knowledge on parallel lines and identifying that x is an alternate angle to our 62 degrees. Now we know x is 62 degrees, we can work out our other angles in our isosceles triangle. Now let's apply our angle facts associated with triangles. Well, we know we have an isosceles triangle, and we know the base angles of this isosceles triangle are the same. So therefore, angle BAC will be the same as BCA. Given we know the sum of angles in a triangle is 180 degrees, angle BAC is 180 subtract our 62 divided by 2, giving us an angle of BAC being 59 degrees. Therefore, the bearing of C from A is 62, add our 59 to give me 121 degrees. Now let's have a look at a slightly harder question. It states that town B is 35 kilometers east and 80 kilometers north of town A. We're asked to work out the bearing of town A from town B and give our answer correct to the nearest degree. As a little hint, we have to use trigonometry. So let's see if you can give it a go and press pause if you need. Well, let's start by identifying what the question wants us to find. Well, we need to start from town B, so we need to identify our north. We're going to town A, so this is the bearing that I'm asked to find. Now, given this is 180 degrees, it's fair to say I just need to simply work out this angle inside our right angle triangle. Now, because I have a right angled triangle, you may have noticed we're using trigonometry. So, using our knowledge on trigonometry, we can see that the 35 kilometers is labelled the opposite length, the 80 kilometers is labelled the adjacent length, so therefore we are using tan to find out our value of x, which I've labelled to be the angle. From here, substituting what we know, well, the opposite is 35 and the adjacent is 80. Because we need to work out x, I'm going to use tan to the minus 1. So x is equal to tan to the minus 1 of 35 over 80, giving me x to be 23.62 degrees. Therefore, I know the angle x and I know this is 180 degrees. So the bearing from B to A is 23.62 degrees, add 180 degrees, which gives us an answer of 204 degrees, correct to the nearest degree. So let's have a look at our last question associated with bearings. Here the question states that the diagram shows positions of two towns, Ampton and Bisham. The bearing of Bisham from Ampton is B degrees, and the bearing of Ampton from Bisham is 6B degrees. We're asked to calculate the three-figure bearing of Ampton from Bisham. In order to do this question, you need to form and solve an equation. There is more than one way to do it, so see if you can give it a go and press pause if you need. Let's start by identifying what we know. Well, we know the bearing of Bisham from Ampton is B degrees. So starting with Ampton, let's identify our north, and we're going to Bisham. From here we know this angle is B degrees. Now the next part of the question states the bearing from Bisham to Ampton is 6B. So labelling this, we know starting from Bisham, which is our north, going to Ampton in a clockwise direction is 6B. We're asked to work out the three-figure bearing of Hampton from Bisham. So we need to solve and form an equation. Well, using our knowledge on co-interior angles, we know this angle here must be 180 subtract our b. From here, you can see we have angles around a point. So let's form an equation. 180 minus our b, add our 6b, must be 360 degrees. Simplifying our expression, we have 180 add 5b equals 360 degrees. Subtracting 180 from both sides gives us 5b is 180 degrees, so therefore b is 36 degrees. Therefore, the bearing of Hampton from Bisham is 6b. We can work this out numerically. The bearing of Hampton from Bisham must be 6 times our 36, which is 216 degrees. In summary, we've gone through two different types of exam questions, questions where you'll need to use a protractor and others where you do not need to use a protractor but have to use a range of different knowledge and skills to tackle the question. If you like this video, please give us a thumbs up. Leave your comments down below and subscribe to this channel so you'll be the first to know when we release our next videos.